Hey guys, welcome to the final video on applications of integration. In this video we're going to go through problem solving by integration. So, what does this mean? Well, when we looked at differential calculus, when we were doing differentiation, we found out or worked out how to find the rate of change of a function by finding the first derivative of it. But if we want to go into a practical situation, then sometimes it's a bit easier if we measure the rate of change and then integrate that back into, or integrate it to find a function to find a quantity that we're concerned with. An example of this might be that we can measure the rate at which electricity is used and then integrate that to find the total amount of electricity used over time. Let's look at an example of this. So the marginal cost of producing X amount of earns per week is given by the following function. And this is in dollars per earn. And that's providing that X lies between 0 and 150. Alright, if the initial cost before production starts are $185, find the total cost of producing 100 earns per day. Keep in mind that 185 as the initial cost. Right, this will be clear in a minute. Alright, so we've got to find the total cost. So what we're going to do, we've got to find a function for cost. Remembering that in here we've got dc dx, which is change in cost over the change in X amount of earns. So what we're going to have to do is find c of x, which is equal to the integral of our function above. Alright, so let's go through, let's work out our antiderivative of our function there. So we've got 2.15, so the antiderivative of that is 2.15x. Take 0.02, though the antiderivative of this is x squared over 2 plus 0.12336 x cubed over 3 plus c. Now, we're told that the initial cost, which would be c naught, is equal to 185. But if you have a look here, we've got an x term here, an x term here, and also an x term here. So if all of these are equal to 0, what we're left with is just c. So c in this case has to be the 185. So our full function, as it stands at the end, is going to be 2.15x. Now 0.02x squared divided by 2 is just 0.01x squared plus 0.0036 divided by 3 well, is just 12 x cubed plus 185. Now, the question initially asks us find the total cost of producing 100 urns per day. Well, all we have to do now is substitute in the value of 100 into our function here, and what we get is $420. So therefore we say that the total cost for 100 and is $420. And that's it. That's really just looking back and seeing what information we've got and how can we use it. Now, a few key points if we look over this again. The initial cost. This helped us find the value of C. So, helps to find C. And more often than not, this value is going to be given to you. It might be the initial cost or it might be X amount of units, but either way you'll be able to work out what the value of C is, as we've done in the past. So that brings me to the end of this video. If you've got any questions, just ask. Hopefully you found it interesting. As always, thanks for watching, and we'll see you in our next topic. Bye for now.